Fun man, so today we're going to talk about chromatography, right?
Chromatography.
Yep. So I mean, we've all done, paper chromatography, right? TLC,
Yeah.
thin layer chromatography, right? There's more advanced things, right? Like HPLC,
Wow.
right?
Okay.
So there's high performance liquid chromatography and there's gas chromatography,
Okay.
right?
Wow.
But all of these, work on the same principle, right? Is that, we have a stationary phase.
Yeah.
We have a stationary phase and we have a mobile phase.
Okay. These two phases will be persistent in chromatography. Any kinds. Tell us more.
Right. So what we want to do in chromatography is that we want to separate down, different molecules and different samples, right? So, what we're actually looking at is the interaction between the molecules.
Right. So this is a separation technique.
Right. So, because we know that, so let's say, stationary phase is very polar and mobile phase is non-polar, right? Then we know that polar molecules will interact more strongly with the stationary phase.
Right. So the concept, how they separate, is really about the difference in polarity. Okay.
Right. So let's say this is polar, non-polar.
And we know that, right? Polar is one end of the spectrum. Non-polar is in the other end, right?
Yeah.
So if you put oil and water together, they don't mix, and oil floats, right?
Yeah.
Which means they can't interact. So we are trying to, move the needle of the interactions between the stationary phase, the solid, right, and the mobile phase. Okay.
Right. And so now what we have is, our mobile phase is flowing, right? But the stationary phase is stationary.
Yes, as the word suggests, right? It's moving, right?
Yeah.
Okay.
So if you interact very strongly with the stationary phase, that means you're gonna cling onto it very tightly, right?
Right.
So you're gonna be left behind.
Right. So maybe I just add this so the audience will know that this is the stationary phase, right? Okay. And this is where your mobile phase. Maybe I can draw this even as a column, right? We blow it up a bit more.
Okay.
How about that? Yeah.
Right. Yep. So this is the theory behind or the idea behind chromatography, right? It's that different molecules interact differently with the stationary and the mobile phase.
Okay.
And so when we make the mobile phase flow through the stationary phase, then different molecules interact differently, and there will be at different points of the column, right? So maybe sample A might be here in this band. Maybe sample B will be further carried down by the mobile phase.
Right. So what you're saying is right. Suppose, okay, the stationary phase is very polar.
Yep.
And then we have got maybe three molecules called A, B, and C. And it goes this direction, top down.
Yep.
Okay. So looking at this, which is more polar? Is it A or B?
So we see that A is more held back, right? So we know that A is more polar because it interacts more with the stationary phase.
Okay, so I will just jot down here to remind the audience that which is most polar. So A is most polar, followed by B.
Yeah.
Okay, maybe I'll put what? Less polar.
Uh-huh.
And then C, let me just put it in, is least polar.
Right.
So that we can see the differentiation here.
And then maybe C will be down here, right?
And what it means, right, Opa, is like, when you pass a mixture of A, B, and C from the top, right, this is how the column runs with molecule. Let's just use like, A, and then B and C, right, all random together.
Yep.
And then, because A is the most polar among all, polar molecules interact better with polar substances.
Yeah.
So that's why it's being held back, like you said, there's interaction here, and it lingers longer. Whereas the other extreme, called C, is not polar, so it's not even interacting. And that's why it's able to flow through more.
Yeah.
And is that the reason why you talk about the bands?
Yeah. So what they do is they separate into bands, right?
Right. So you see that A becomes one band, and then B becomes another band, and C becomes another band, and they're now separated.
Yeah.
Okay.
Alright, so for the next video, we're going to talk about the applications of chromatography techniques, in real life. So watch out for that next time.
Stay tuned.